Persistent Programmer here, and today we're going to do another Leetcode question, sort colors. So this question asks us to sort um, three colors, red, white, and blue, which are given in the form of 0, 1, and 2. So 0 is our red, and then 2 is our blue. So I'll just write this down here. So 0 is red, 1 is white, and 2 is blue. So eventually what we want to do here is we want to return this list that we're given, this input of ints, um, and we want to return it in a sorted list. And the problem with solving this question is that they are telling you you cannot use a sort function, so you have to sort them in place by yourself, which makes this problem a little bit harder to solve, right? Because you can't just go ahead and use the sort function and that's done already. Okay, so let's go ahead and look at the solution and see how we can tackle this problem. Okay, so the intuition behind this problem is really to think about um, how to sort this array in terms of having two categories. And we can think of having a blue category where we put all our twos, and we can think of all the zeros which are going to be in the beginning as a red category. So all the zeros need to end up here, and all the twos need to end up here. So if we do this, what's going to happen is we're going to end up with just the ones in the middle. So let's go ahead and write this out. So in this current input, we have two twos, right? So we have 2 and 2, and then we have two zeros, which should be here, and we have two ones, right? So to track all of this, what we need to do is we need to have pointers in this list to help us iterate over and achieve this organization where we put all the twos at the end of the list and all the zeros at the beginning of the list. So this intuition is very useful to understand this solution if you think of it as a blue bag and a red bag that we're trying to keep our sorted items in, right? So I'm gonna go ahead and initialize these pointers here, so we know how the algorithm works, and we can walk through a use case and some pseudocode to get familiar with how to do this. So I will say that this pointer here is the L pointer, and this pointer here can be the R pointer, so left and right, and then this is the C pointer. Now, the goal of each of these pointers is to move the item where it belongs. So you see here, 2 is a blue item, right? So that's why I've made this blue, right? So 2 here is a blue item, and we need to move this to the back, right? So we need to move this over here, right? And if we look at 0, this is a red item. This should be in the beginning, and we need to move this over here. So what is the most simple way of doing this, right? What we can do is we can just define a swap function and swap these two places. And essentially that's the whole idea behind this problem, is to keep swiping until we have the organized items in the list. Okay, so after we have swapped these two positions, our transformed list will look like this. So we have the 0 in this spot where the 2 was, and the 2 is all the way over here where our right pointer was initialized, remember? So R is a right pointer, and that was initialized here. And now, since we're done with this spot, we know that for sure in the last spot there's going to be a 2. We can move our right pointer over. So our right pointer will currently be sitting at over here, and our left pointer is still at our initial position. The left and current are still at their initial position here. Okay, so what happens in the next iteration after that? So after that, we see that our left pointer here, and so we're going to check by the current pointer. So our current pointer is 0, and when there is a 0, we know that 0 is in the right spot. It's in its correct red spot, right? So we don't do anything. So we'll move our left pointer and our current pointer over. So we'll move them over. And in this next spot, there's also a 0. So we know that it's in the right bracket. See, it's in the red bracket here. It's in the correct place, right? So we don't need to do anything. And then, so in our next iteration, what happens is this 2 is encountered. And in this case of the 2, we know that it's in the wrong bracket because it's supposed to be at the back, and it's supposed to be in the blue bracket, and it's not. So this is where our current pointer is going to be, and our left pointer as well. And this is where our right pointer was. So from here, it didn't move, it was still here. So what we do is we do the swap again. And when we do that swap, we have this 2 in this position where the 1 was, and the 1 moves over, right? So do you see how this transforms the list, where all we're doing is we have a current pointer to indicate where, like, we're navigating the list with the current pointer, and we're just pushing the 2's to the end by swapping them, and then every time we see a 0, we want to make sure that they're on the left side in the red bracket here. So that's essentially the idea of solving the problem. Now I'm gonna go through some pseudocode before we look at the solution, and maybe some edge cases that need clarifying. Let's review in our pseudocode what we need to do. So if we see a 2, if our current navigator brings us to a 2, then what we need to do is we need to move it to the back, and we want to decrement our right. So when we move this 2 to the back, we're done with this spot. So we moved our right pointer over. So we want to say if nums at the index of cur is equal to 2, right? So if this is the case, then we want to swap. So we can say swap. So we're going to swap our current position and our right, okay? And we're going to decrement the counter of right. So those are the steps that we need to take when we see this 2. And let's go ahead and look at the other cases. So what if we see a 0, right? What did we do in this case? So we could have a situation where we are given this kind of list where we have 1, 0, and 1, right? So when we see a 1, we just don't do anything because we know the 1s will organize themselves, so we just move our current forward. So let's say we had this list, and our cur was here and our left is still here, right? Now when we see a 0, we need to move it towards the left. We need to make sure that it's in its right bracket, so it needs to be moved this way. So how do we do that? So we can say that every time we see a 0, just swap it with the current position, right? So for this case, when there's a 0, we need to swap the current position. So we'll swap cur and our L. So that's what we need to do. And after that, we need to move both our current index and our left index forwards because we're done with this spot, right? So after this is swapped, it will look like 0, 1, 1. So we're done with this spot. So we know that the 0 is in the right place, so we can move the left index forward and also our current index forward. So that's what we need to do when we see a 0. And lastly, when we see a 1, we just move our current pointer forward because we know that the 1s will organize themselves naturally if we're able to just contain the 2 in the blue container and our 0 in like our red container. So as long as we're able to separate these 2 in the list, the 1s will just fall into their place because they have nowhere else to be organized besides the middle. Okay, so I hope this makes sense. I know this is not really the easiest question to solve, but I hope this explanation helps you guys out and you're able to understand and write the code. Okay, so let's go ahead and move on to the code. Awesome. So I'm back in Leetcode, and what I've done here is I have just defined a swap function here, which is going to help us do the swaps really easily. So we're not adding this logic in the main code. It's just easy to have a separate function that does just swapping. If you want me to go into more detail on how this function works or how to write your own swap functions, let me know in the comments below. Otherwise, let's just go ahead and write our main code. So the first thing I'm going to do is say we'll define our right and left. So we'll say L equals 0 and we'll say cur equals 0. So cur is going to be our navigator, and this is what's going to move us forward. And we'll say our right is going to be the length of the nums minus 1, since we're starting at 0. And after we have these three defined, we're going to do a while loop and say while cur is less than equals r. So r is our right bound. Okay, so after we do that, we need to check what our current value is in our list. So we'll say if nums cur is equal to 2, right? So if we encounter a 2, what do we need to do? If the current number is 2, then we need to move it back, right? So we need to say swap. Okay, so if my current number is 2, I want to swap myself to the back of the list, right? So we'll say nums, and so this function is written in a way where it takes the list and then the 2 indexes that need to be swapped. So we'll say nums, and then we need to send it the current position. So this is where it currently says 2, and it needs to be moved back. So the rightmost position is the right index. So I'm going to send the right index here. Yeah, so this is what our swapping will look like. So it just takes the current and the right, and it's going to put this current 2 to the rightmost part of the list. Okay, and once we've done that, we can decrement the right. So we can say right minus equals 1. Okay, and the next thing we need to check is if we encounter a 0. So we can say elif nums cur is equal to 0. If we see a 0, then we also need to do the swap, right? So we can say self.swap. So I'm going to swap myself, this current pointer, so cur, and we're gonna swap it with the leftmost part of the list. So we're gonna swap it with the left index. And after that, we're gonna move the cur 1 forward, so plus equal 1. And this is a case we discussed in with the sample where we only had 1, 0, 1, like why we need to swap the cur and the left in this case. So, and then L is going to be plus equals 1 as well. And lastly, if we just see a 1, then we don't need to do anything, no swapping, we'll just increment the cur so we can move forward in our list. So cur is plus equals 1. So that's how we're going to move it forward. Okay, so yeah, this is the entire problem. Think it looks good. Yeah, don't see any typos. Okay, let's go ahead and give it a run. Okay, yeah, looks like it works. Okay, submit. Okay, awesome, it works. Thanks guys. If you like this video, please go ahead and subscribe to the channel, give this video a like, and if you have a different solution, please post it in the comments below. It could be in any other language. It's just gonna help other people look at the solutions and understand and solve this problem themselves. Thanks guys, happy coding!